Hi everyone. So our topic for today is Gmdas or Pmdas. So we are going to solve this problem. So I will show to you how to solve this problem. So by the rules in Pmdas or Gmdas, we are going to solve first the operations inside the grouping. So for the first operation, it's equal to that's 18 divided by 6. So we have to solve first the division before the addition because P stands for the parenthesis or the groupings, and then multiplication, and then the division. And then we have the addition, and as far as subtraction. So according to this series of operation, we are going to solve first the division since there is no division, there's no multiplication inside the groupings or the parentheses. So we're going to solve first 18 divided by 6. So what is 18 divided by 6? That is 3. And then just copy plus 3. And then copy the multiplication sign. And then let's do first the 5 times 9 because that's the first operation that we have to solve according to the Pmdas or the Gmdas. So 5 times 9 is 45, and then just copy minus 7. So still, they are still inside the parentheses, so we have to solve first the problem inside the groupings before doing the multiplication. So what is 3 plus 3? And that is 6. And then times, what is 45 minus 7? 45 minus 7. And that is 15. Okay, 15 minus 7, that's 8, and bring down 3. So that is 6 times 38. So we're going to solve 6 times 38. So 8 times 6, that is 48. Carry 4. 3 times 6 is 18, 19, 21, 22. Okay, so that is, the final answer is 228. So remember, always follow multiplication and division first before addition and subtraction. If ever the multiplication and division are included in the series of operation at the same time, okay, you have to solve multiplication first before the division, or you have to solve the operation whichever comes first from the left. Okay, and then if there is addition and subtraction in the series of operation, you have to solve first whichever comes first, whether it's addition or subtraction. So as long as you're going to solve multiplication and division before addition and subtraction. Okay, next problem. We're going to find the sum of 24 divided by 8 times 3, and then the answer in 16 minus 3 plus 1. So let's apply the Gmdas rule. Okay, multiplication and division first before the addition and subtraction. Okay, whether they are in the groupings or inside the parentheses, you have to solve first the multiplication and division before the addition and subtraction? Well, if they are both in the series of operation without the groupings, you have to follow what the operation that comes first. You have to solve for that, whether if it's division comes first or multiplication comes first. You have to solve for that first before the addition or subtraction. Okay, for this problem, we have two groupings here, which is 24 divided by 8 times 3. So let us solve first 24 divided by 8, not 8 times 3. Why? Because the division comes first in the series of operation. So what is 24 divided by 8? And that is 3. And then just copy the times 3. Do not forget the parenthesis and then copy the addition sign. Okay, we're going to solve first here the 16 minus 3. Why? Not 3 plus 1 because the subtraction comes first, okay, in the series of operation. Okay, so that is 16 minus 3. What is 16 minus 3? That is 13 plus 1. Okay, so they are still in the groupings. And 3 times 3. What is 3 times 3? That is 9. Okay, no need to put the parenthesis and then copy the addition sign. And then what is 13 plus 1? And that is 14. And what is 19? And 14 plus 9, 4 plus 9, that is 13. Carry 1 and 1 plus 1, that is 2. So your final answer here is 23. Okay, for the next problem we have, so this one is a complex one because as you can see, you have many groupings. You have here, you have the braces, the bracket, and you have the parenthesis. So the rule here is you have to solve first the inner grouping, and the inner grouping you have here is the 12 minus 9. So that's the first problem that you're going to solve, or the first operation that you're going to solve, because this is the inner grouping. So let's just copy this one. 2 times, do not remove the braces, 6 plus, do not remove the bracket, just copy, 24 divided by, and then so let's solve this one. What is 12 minus 9? And that is 3, right? And no more adding the parentheses here. Just put the bracket and copy the braces. Okay. And what is the inner grouping that you can see here right now, which is the 24 divided by 3, right? So that's the operation that you're going to solve first. So just copy this one, 2 times 6 plus, okay, we are going to remove now the bracket here because we're going to solve the 24 divided by 3. What is 24 divided by 3? And that is 8. And then the braces. Okay, just copy again. 2 times, what is 6 plus 8? We're going to do now 6 plus 8 because this is still in the grouping. So 6 plus 8 is 14. Okay, so there's no grouping anymore. That's the time we can solve 2 times 14. And what is 2 times 14? Times 2. 4 times 2, that's 8. 1 times 2 is 28. So your final answer here is 28. Okay, next one. We can see here it has multiple groupings again. So we have the braces and we have the parentheses here. Minus 9 is not included in the groupings, okay? So let's do, let's just copy this one. 36 plus, so we have to solve first the inner grouping, which is 18 divided by 9 plus 25. So you have two operations here, which is the division and the addition. So we have to do the division first, okay? So that's 18 divided by 9, and that is 2 plus 25, and still copy the parentheses and the braces, and then minus 9. Okay, and then still copy the 36 plus, what is 2 plus 25, and that is 27. No need to copy the parentheses, just the brace, and then minus 9. So the operation here inside the grouping is 36 plus 27. And what is 36 plus 27? So 6 plus 7, 13, carry 1, 3 plus 2 is 5 plus 1 is 63. Okay, that's the time we can remove the braces and copy the minus 9. Okay, let's solve for now the 63 minus 9. 63 minus 9. 3 minus 9 cannot be. Okay, borrow from 6. This will become 5. 3 will become 13. 13 minus 9 is 4. And bring down 5. So your final answer here is 54. Okay, next one. We have groupings here inside, as you can see, but the inner grouping here is 25 divided by 5. So let's just copy 14 times 3 plus 12 plus, copy the brace, 12 plus, what is 25 divided by 5, and that is 5. Okay, and then remove now the parenthesis. There's only the brace. Then minus 4 times 10. So we still have groupings here, which is 12 plus 5. So we still have to solve that. I'll just copy the remaining operation, 14 times 3 plus 12 plus 12 plus 5, and that is 17. And then remove the brace, copy minus 4 times 10. Okay, now we have, how many operations do we have here? Do we have multiplication? We have addition and subtraction. So we have to solve first the multiplication. As we can see here, we have to solve 2 multiplication here, which is 14 times 3 and 4 times 10. So 14 times 3, that is 42, right? 42 plus 12 plus 17, and then 4 times 10, and that is equal to 40. So minus 40. So we already solved the 2 multiplication. Okay, next one. Okay, so since addition, we have addition and subtraction now. So since addition comes first in the series of operation before the subtraction, so we have to solve first all the addition here. So let's add 42 plus 12. That is 4 and 54. So we solve this one first so that I will not be confused, okay? So 54 plus 17 minus 40, just copy minus 40. And then let's do now the 54 plus 17. 54 plus 17, 4 plus 7 is 11, carry 1. 5 plus 1 is 6 plus 1, that's 71. 71 minus 40. And what is 71 minus 40? So 1 minus 0, just bring down 1. 7 minus 4, that is 3. So your final answer here is 31. Okay, let's solve the next problem. As you can see here, we have groupings here that involves the bracket, the brace, the bracket, and the parenthesis. So which one is the inner grouping here that we have to solve, which is 54 divided by 6. So let's focus on this one first. So just like before, just copy first so that you will not be confused. Copy the numbers that you will not solve first. So base 49 plus bracket 8 times, and then solve 54 divided by 6. And what is 54 divided by 6? And that is 9. And then no need to put the parentheses anymore, just only the bracket. Okay, and the braces. Why do we have to still put the brace? Because they are still in the groupings. Remember, we still have 49 here. Okay, and then just copy minus 27. 27 here is not in the grouping, so it will be the last one. So from here, the inner groupings we have is the 8 times 9. So let's solve that first. Copy the brace, 49 plus, and what is 8 times 9? That is 72. Don't forget to copy the addition sign, and then plus 72. Okay, and then no need to copy the bracket anymore, just only the brace. Minus 27. Okay, we still have some grouping here, which is 49 plus 72. So we have to solve that first. 49 plus 72. 9 plus 2 is 11. Carry 1. 7 plus 4 is 11. Plus 1, that is 2. That is 12. So you got 121 here. And then just copy again the 27 minus 27. And then let's solve 121. 121 minus 27. 1 minus 7 cannot be, but 1 from 2. This will become 1. This will become 11. 11 minus 7, and that is 4. And then 1 minus 2 cannot be, so this will become 0. This will become 11. 11 minus 2, and that is 9. So the final answer here is 94. Next topic is the greatest common factor. So what is GCF, or greatest common factor? It is the highest or the greatest number that is a factor of the numbers. It is also important that we know what is a prime number in getting the GCF. So what is a prime number? It is a number that has only two factors, the number one and itself. Example, 3 is a prime number. Why? Because the only factors of 3 is 1 and 3. So if we multiply 1 times 3, that is equal to 3. There's no other factors of 3. Next one is a composite number. What is a composite number? It is a number that has 3 or more factors. Example is 12. 12 is a composite number because the factors of 12 are 1, 12, 2, 6, 3, and 4. How did we get this number? Okay, so because 1 times 12, that is equal to 12. If we multiply 6 times 2, that is equal to 12. If we multiply 3 times 4, that is 12. Okay, so we got 1, 2, 3, 4, 12, and 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So those are the factors of 12. Okay, how do we find the GCF? So we have three methods. We have the listing method, we have the prime factorization, and we have the continuous division. For the listing method, we have to list all the factors of the certain number. Like for example, what are the factors of 32? So we listed here 1, 2, 4, 8, 16, and 32. How did we get that? So 32, the factors of 32 are, if we multiply 1 times 32, that is equal to 32. If we multiply 4 times 8, that is equal to 32. If we multiply 2 times 16, that is equal to 32. Okay, so do we have some more? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There you go. So these are the factors of 32. Now, how did we get the factors of 40? Because if we multiply 1 times 40, that is equal to 40. If we multiply 2 times 20, that is equal to 40. If we multiply 5 times 8, that is equal to 40. And if we multiply 10 times 4, that is equal to 40. So we have 1, 2, 3, 4, 5, 6, 7, 8. So you have 1, 2, 3, 4, 5, 6, 7, 8. Okay, we listed all the factors here of 40. Now, after we list all the factors of 32 and 40, you have to get the greatest common factor here. And what is the greatest common factor that you can see here on the list? It is, okay, so we have 4 common factors. We have 1, 2, 4, and 8. And the greatest number is 8. So the greatest common factor of 32 and 40 is 8. Okay, now let's get the GCF of 12 and 8 using listing method. Okay, so let's try one. So 12 here and 8. So what are the factors of 12? If we multiply 1 times 12, that is 12. If we multiply 2 times 6, that is 12. If we multiply 3 times 4, and that is 12. So we have to list 1, 2, 3, and then we have 4, 6, and 12. Next, we list the factors of 8. So 8, if we multiply 1 times 8, that is equal to 8. If we multiply 2 times 4, that is equal to 8. So that's it. So let's list 1, 2, 4, and 8. Okay, so we have, how many common factors do we have? Let's encircle it. So 1, 2, and 4. So the greatest common factor of 12 and 8 is 4. So this is your answer. Next, finding the GCF by using prime factorization. So let's find the GCF of 30 and 48. Okay, so how did we get this 5 times 3 times 2 and 2 times 2 times 2 times 2 times 3? Okay, so we have to factor out each. Okay, 30. What are the factors of 30? 6 times 5. Okay, 5 is already prime number. You cannot factor that one out. And then 6 is a composite, so you can still factor them out. So that is 2 and 3. So that's why we get this one, because this is 3. Okay, we have 5 and 2. Okay, so those are the prime factorization of 30. Next up, how about 48? So let's factor out 48. We have 6 times 8. Factor out 6. This one also, 8. We can also 2 and 3, or 2 times 3. 8 is 4 times 2. So this is already a prime, this is a composite, and this is a prime. So we can still factor this 4, which is 2 times 2. And then you copy this, the prime numbers here. So that's why we got 2. We got how many 2's? 1, 2, 3, 4. 2 times 2, 1, 2, 3, 4, and then times 3. Okay, after you do the prime factorization, okay, you have to encircle all the common prime numbers here. So in here, the common is 2 and 3. So you have to multiply the 2 prime numbers that are common to both, which is 2 and 3. And 3 times 2, that is 6. So we have to multiply them. And the GCF of 30 and 48 is 6. Okay, let's find, okay, this one is the process where we get the prime factorization. This is the other way. Okay, the one that I used a while ago is 6 times 8. This one, the factors of 48 here is 2 times 24. So you can do this also. Okay, and then you get the prime numbers. So that's it. Now let's get the GCF of 6 and 24. So through prime factorization, 6 and 24. So let's factor this one out. It's 2 times 3. Okay, these are already prime numbers. How about 24? Factors of 24 is it's either 6 times 4 or 12 times 2. Okay, any of those, you can use it. So it's 2. I will use 2 times 12. Okay, and this one, we can still factor this one out. What are the factors of 12 is 6 and 2, or 6 times 2. And this one, factors of 6 is 2 and 3. So they're already prime numbers here, 2, 2, 2, and 3. This one also already a prime number, so let's list them. So for 6 is 2 times 3, and for 24 is 2 times 2 times 2 times 3. So how many common factors do you have here? So you have 2, and you have 3 here, times 3. Okay, so the GCF What is 2 times 3? The GCF is 6. So that is the GCF of 6 and 24. Next, let's get the GCF of 6, 12, and 18 using continuous division. Okay, first we have to divide the numbers using the smallest possible number. Okay, remember, you have to think of the smallest possible number. Okay, so which number or which is the number that is divisible to 6, 12, and 18? So 2. So 6 divided by 2, just put your answer here below, which is 3. 12 divided by 2, and that is 6. 18 divided by 2, and that is 9. Okay, so 3, 6, 9, you can still factor them, you can still divide them to certain to a prime number. So do not stop until you until you get the numbers here below all prime numbers. Okay. Since this one is already prime number, but 6 and 9, 6 and 9 are not yet prime numbers. Okay, you can still divide them both to as smallest possible number. Okay, so all of them is divisible to 3. So 3 divided by 3, that is 1. 6 divided by 3, that is 2. And 9 divided by 3, that is 3. So 1, 2, and 3 are all prime numbers. Okay, you can stop here now and then just get the numbers beside this one. Okay, just get the numbers and multiply them. So get the prime numbers common to all and multiply the divisors to get the GCF. And the GCF of 6, 12, and 18 is 6. 2 times 3 is equal to 6. Okay, let's get the GCF of 2, 14, and 18 using continuous division. So I will list down 2, 14, and then 18. Okay, what is the smallest possible number here that we can divide to 2, 14, and 18? Okay, you are correct. It's 2. So 2 divided by 2, that is 1. 14 divided by 2, that is 7. 18 divided by 2, that is 9. Okay, so are we going to stop here now? Yes, that is correct, because there's no common number that is both divisible to all of this number 1, 7, and 9. So it means your GCF for 2, 14, and 18 is 2. Okay, next one. Let's find the GCF of the following. I will give you 1 minute each to solve the problem. So 1 minute for number 1, 1 minute for number 2, and 1 minute for number 3. Let's start now. So the GCF of 18 and 36 is 18. The GCF of 18, 27, and 45 is 9. The GCF of 15, 25, and 50 is 5. So how do we get it? So let's try to solve 18 and 36. Let's use continuous division. 18 and 36. So let's divide this to 2. 18 divided by 2, that is 9. 36 divided by 2, that is 18. We can still divide them both by 3, right? So 9 divided by 3, that is 3. And 18 divided by 3, and that is 6. We can still divide them to 3. 3 divided by 3 is 1, and 6 divided by 3, that is 2. Okay, let's get now the prime number here, and then let's multiply all of them. 2 times 3 times 3. So what is 2 times 3? That is 6. And 6 times 3, that is 18. Okay, so that's why your answer here is 18. Next, how about 18, 27, and 45? Okay, using continuous division. Okay, all 18, 27, 45, all of them is divisible by 6. No, they're all divisible by 3, right? So 18 divided by 3, that is 6. 27 divided by 3, that is 9. And 45 divided by 3, and that is, I think it's 15. 5, yes. So it's 15. Okay, next. 6, 9, and 15 are all divisible again by 3, right? So 6 divided by 3 is 2, 9 divided by 3 is 3, and 15 divided by 3, and that is 5. Okay, so you can stop here now because there's no number that is divisible to all of them. So let's get the numbers here beside 3 times 3, and that is equal to 9. So your answer here is 9. Now let's solve 15. You see, I have 15, 25, and 50. So all of them are divisible by 5, right? So 15 divided by 3 is 15 divided by 5, that is 3. 25 divided by 5, that is 5. And 50 divided by 5, that is 10. Okay, so all the 5 and 10 are divisible by a certain number, which is 5, but this one is not divisible by 3. So you can, this one is not divisible by 5, so you can stop now here. Get the number here. That's why your answer here is 5. Okay. That's it for today. Okay, next topic is the LCM. So what is the meaning of LCM? It is the lowest number that is a multiple of the given numbers. So how do we find the LCM? So there are 3 methods. We have the listing method, prime factorization, and continuous division. So in these methods, in getting the LCM using these methods are very different from getting the GCF. So let us find out more about the methods. First is the listing method. So let's find out the LCM of 3 and 5 using the listing method. So in here, we are going to list all the multiples of these numbers by skip counting. So the multiples of 3 and 5, just use the skip counting by 3. So 3, 6, 9, 12, and 15. The multiples of 5 by using skip counting by 5, that is 5, 10, 15, and 20. Okay, and then now we have to identify what number is common to both 3 and 5, and that is the least number. So we have 15. 15 is the least common multiple of 3 and 5. Next method is the prime factorization, or what we call the factor tree. So in doing the prime factorization, let us find out the LCM of 8 and 12. So let's factor out 8. The factors of 8 is 4 and 2. 2 times 4, that's equal to 8. And then we can still factor out 4. 2 times 2, that is equal to 4. Then let us factor out 12. the factors of 12 are 2 and 6, because 2 times 6, that is equal to 12. And then we can still factor out 6. So the factors are 2 and 3, because 2 times 3, and that is equal to 6. And then we encircle all the prime numbers. And then we list down here. So the prime factors of 8 are 2, 3 twos. So, and then the prime factors of 12, that is 2 twos and a 3. Okay, as you can see here, we listed them all, but 3, we have to remember that you have to bring down all the common prime factors. So we bring down 2 here. We bring down 2 here again. Okay, and then we can, in getting the LCM using prime factorization, numbers that are not also common to both, you should bring it down here so that you can multiply it. And then also this one, the 3. So, and then multiply them all together. So 2 times 2, and that is 4, and 4 times 2, and that is 8, and 8 times 3, and that is 24. So the GCF of 8 and 12 is 24. Okay, next method is continuous division. Let us find out the LCM of 6, 12, and 18 using continuous division. List them all here, the numbers, and then think of the least prime number that is multiple to this 3, and that is 2. Okay, and then 6 divided by 2, you just write all the quotient below. 6 divided by 2, and that is 3. 12 divided by 2, and that is 6. 18 divided by 2, and that is 9. Okay, and then 3, 6, and 9, you can still divide them all by 3. 3 divided by 3, and that is 1. 6 divided by 3, and that is 2. 9 divided by 3, and that is 3. Okay, here we have a different approach here. So remember in the GCF, in the continuous division, we have to multiply the divisors or the number on the left side here. But in this getting the LCM, we have to multiply all the divisors and also the quotient below. So that is why 2 times 3 times 1 times 2 times 3. If you multiply all of them, you will get 36. So the LCM of 6, 12, and 18 is 36. Okay, so here is another example which different from the first one, but we will still be using continuous division. Okay, so follow the steps. Number 1, first we write all the numbers in a row, separating them by a dash or comma. So in this case, we are going to find out the LCM of 6, 10, and 18. Okay, and then we divide by a least prime number, which divides all the given numbers, and that is 2. So 6 divided by 2. Okay, and then for the step 3, we put the quotient directly under the numbers in the next row. So 6 divided by 2, and that is 3, and 10 divided by 2, and that is 5. 18 divided by 2, and that is 9. For step 4, we continue the process. So a number will remain as it is if we can't divide it. So we directly write under the numbers in the next row. In this case, 5 Okay, 5, we can't divide that to 3, right? So we will remain as it is. We will just write that number on the next row. Okay, so let's start dividing. 3 divided by 3, and that is 1. And then 5, just write as it is. And then let's divide 9. 9 divided by 3, and that is 3. Okay, and then we multiply all the prime numbers by which we have divided and the co-prime numbers left in the last row. So just bring down 1, 5, and 3 here. And then we multiply all the prime numbers, which are 2 times 3 times 1 times 1 times 5 times 3. Or you may not do this one. You may skip 1 and 1 here because your answer will still be the same. Okay? So whether you skip this one or whether you delete this one or you will write this one here, the the answer is still the same. So the answer of 2 times 3 times 1 times 1 times 5 times 3, and that is 90. So the LCM of 6, 10, and 18 is 90. Okay, now let's practice. Find the LCM of the following numbers. Number 1, 12 and 35. Number 2, 81 and 108. Number 3, 18, 54, and 27. And then number 4, 36, 45, and 60. And then for number 5, 33, 77, and 60. So you may pause this video to allow you more time to solve the LCM. You can pause the video for 3 to 5 minutes to find the LCM. Okay, let us find the answer. For the number 1, the answer is 12 and 35. So how did we get it? So I will use here the prime factorization. 12 and 35. So what are the factors of 12? 6 times 2. We can still factor out 6, and that is 2 times 3. And then we list here the prime numbers, which we have 2 2's and then 3. Next, we have what are the factors of 35? We have 5 times 7, right? Because 5 times 7, that is equal to 35. And then we list down here. Okay, so since we are going to list down 5, 7 here. Okay, just bring down 2 times 2 times 3 times 5 and then times 7. Okay, so what is 2 times 2? And that is 4. 4 times 3, and that is 12. 12 times 5, and that is 60. 60 times 7, and that is 60 times 7, 0. 6 times 7, 42. Okay, so the LCM is 420. Okay, did you get it? Did you get the correct answer? Okay, let's move on to LCM of 81 and 108. So let's do prime factorization again. The factors of 81 is 9, right? Because 9 times 9, that's 81. And then we can still factor out 9 here. And then let's list here. So how many 3's? You have 4. 3 times 3 times 3 times 3. And then how about 108? 108. Okay, so factors of 108 are 9 times 12, right? And then we can still factor out 9, which is 3 times 3. And then how about 12? Yeah, how about 12? And that is 4 times 3. Okay, next one. You can still factor out 4 here. 2 times 2. Okay, encircle all the prime numbers. And then list down here. So how many prime numbers do we have here? So we have 3's. 3 times 3 times 3. And then we have 2's. How many? 1, 2, 3. 1, 2, 3. And then we have 2's times 2 times 2. Bring down here, 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 here. So 3 times 3 times 3 times 3 times 2 times 2. Okay. So 3 times 3, and that is 9. 9 times 3, that is 27. 27 times 3, and that is 81, right? 81. 81 times 2. 81 times 2. And that is 162. And another 2 here. 162 times 2 again. So this is 4. 6 times 2, that is 12. 1 times 2, and that is 2 plus 1. That's 3. So we got 324 here. Okay, next is LCM of 18, 54, and 27. So let's find out the factors of 18 first. So it's 6 times 3, right? 6 times 3. You can still factor out 2 times 3. So they are all prime numbers. List down here the prime factors of 18, which is 2 times 3 times 3. Next one, how about 54? Okay, the factors of 54 are 9 times 6, right? So we can factor out 9, which is 3 times 3, and 6, which is 2 times 3. So they are all prime numbers, right? 3, 3, 2, and 3. So we list down here how many 2's. You have 2's, and then you have 3 3's. Times 3 times 3 times 3. Okay, next up is 27. Okay, for 27, we have the factors are 9 times 3, and we can still factor out 9, which is 3 times 3. So you have 3 3's here. So for 27, let's list down how 3 3's. 3 times 3 times 3. Okay, and then bring them all down. This is 2 times 3 times 3 times 3. So 2 times 3, that is 6. 6 times 3, that's 18. And 18 times 3, that is 8 times 3, 24. Carry 2, 1 times 3, that is 3 plus 2. That is 54. So the answer here is 54. Next, LCM of 36, 45, and 60. 36. So the factors of 36 is 6 and 6, right? 6 times 6. You can still factor this one out, 2 times 3. And this one, 2 times 3. So we have 2 2's and 3 3's. 36, 2 times 2 times 3 times 3. Next, how about 45? So factors of 45 are 9 times 5, right? And then we can still factor out 9, which is 3 times 3. List down all the prime factors. 45, so we have 3 3s and 1 5. So 3 times, okay, we have 2 3s. Okay, correction, 2 3s and 1 5 times 5. And then next, 60. Let's find out the factors of 60. Okay, 10 times 6, right? And then this one is 5 times 2. And this one is 2 times 3. So they're all prime numbers. So 60. How many 2's you have here? You have 2 2's. 2 times 2. And then we have 1 3. This one. And then we have 5 times 5. Okay. Just bring down all the prime numbers. 2 times 2 times 3 times 3 times 5. Okay, what is 2 times 2? And that is 4. 4 times 3, and that is 12. 12 times 3, that is 12 times 3, 6, 36. And 36 times 5, 36 times 5, 6 times 5, 30, carry 3. 3 times 5, 15, plus 3, that's 18. So your LCM here is 180 or 180. Next. Okay, for number 5, let's find out the LCM of 33, 77, and 60. So the factors of 33 are 11 times 3. So list them here. 11 times 3. How about 77? 11 times 7. So this is 11 times 7. Okay, and then how about 60? 60, which is 10 times 6. And then we have 5 times 2. And we have 2 times 3. Okay, so they are all prime numbers. 60. We have 2 2's here and 1 3. Okay, so sorry. So we have 3. Let's put 3 here first. 3 times 2 times 2 times 5. Okay, bring down all the numbers. 11 times 3 times 7 times 2 times 2 times 5. So 11 times 3, that's 33. 33 times 7, that's 33 times 7, 21, carry 2, 21, then 231. 231 times 2 times 2, and that is 2, 6, and 4. 462 times 2, that is 4, top, carry 1. 924. 924 times 5, that is 20, carry 2. 10, 11, 12, 12, carry 1. 9 times 5, 45, plus 1, 46. So you got 4,620. LCM of 33, 77, and 60.